Hi, this is Miss Sec. This is the warm-up. But for us to talk about the warm-up, first we need to talk about some vocabulary words. I hope last week you were taking notes in a math journal because I'm about to give you some notes. So you might want to put this video on pause, go get your math journal, and start taking some notes because this warm-up has a lot of vocabulary words that I'm not sure that you guys know all the definitions to. So before we read these statements and determine if they're true and false, let's talk about the vocabulary word. So first vocabulary word is the word function. And the second vocabulary word is the word relation. Then we have the words input and output. So let's talk about what these mean before we answer these questions and determine if they're true or false. So we had talked about last week the definition of a function. A relation is a function if for every input there's exactly one output. Okay, what does input and output mean? The input is the x and the output is the y. The input and output can be represented like this in the table. So the input is on the left side and the output is on the right side. If the table was looking like this, the input would be on top and the output would be on the bottom. Notice the input always comes first. So no matter which way the table looks. And when you're talking about a graph, the input is the horizontal axis, the x-axis, and the output is the vertical axis, the y-axis. So a relation is a function if for every input there's exactly one output. That's what we talked about last week. Now, what is a relation? So a relation is data that can be represented as ordered pairs. So you can represent a relation as ordered pairs. Okay, you can represent a relation as a table. You can represent a relation as a mapping diagram because an arrow goes from the input to the output, and you can represent a relation as a graph. Okay, so now let's go back to the question at hand. So question number 1. Every function is a relation. So yes, for it to be a function, it can be represented as ordered pairs. So this answer is true. Every relation is a function. No, not every relation is a function. It's only a function if every input has exactly one output. That should not be no. That should be false. Okay, so let's put an F here. Okay, now, when you switch the inputs of and outputs of any function, the resulting relation is a function. Well, remember, a relation is a function if for every input there's exactly one output. So that is false. The presence of repeated input values determines if relation is a function. That is true because for every input, there's exactly one output. So if the input is repeated, then it's not a function. The values of the output do not determine if the relation is a function. That is also true. It is the values of the input that determines if a relation is a function.